or so of BPEarthWatch uploading video after video about Comet 209P linear, making all kinds of ridiculous, doom-mongering, fear-mongering claims. You can see in the video titles here things like incoming debris cloud could strike major cities, the shaking of the Earth, linear's giant debris field, new images, etc., etc. And I've actually been getting messages about this from people concerned about it. So we're going to address these claims, we're going to take a look at these videos, and see what the deal is. So in this first video, he presents what he claims is Comet 209P and the stereo-ahead HI2 images. So let's listen in.
Here's linear coming in. It's still about to do its arc as it comes back through. You got
It's arc, okay, whatever that's supposed to mean. I'm sure that's the technical term, right? So he shows what he claims is linear there. And I've taken these images from the raw data on the stereo website and cropped down on that comet. And you can see here I've processed it. I processed the raw data to preserve the stars in the image so I could astrometrically solve it. And you can see there is indeed a comet present in these images. And you can see the astrometric solution here. I'll include this link in the video description so you can take a look for yourself. And you can see, okay, so we've got Arcturus up here. The comet's in the center of the image, and now we have the coordinates for the center of the image, so we can take a look and see what stereo-ahead should see from its position in space when looking at those coordinates. So I've got that loaded up here in Starry Night Pro, and you can see at 13 hours, 30 minutes right ascension. Let's look again at those coordinates just so you can see. So 13 hours, 30 minutes right ascension, and about 18.5 degrees declination. And at 13 hours, 30 minutes right ascension, and about 18 degrees declination, we have Comet Lovejoy C2013 R1, a completely different comet than the one he's claiming. This comet is not coming particularly close to Earth, especially compared to Comet Linear. Now, Linear will be making a close approach by Earth, and it may even give us a meteor shower in May, but it's a very minor periodic comet, and it's not even the closest comet to come by Earth in our lifetimes. There was one that was much closer in 1983. And that one also left a meteor shower for us. And guess what? We're all still here, but more on that later. You can see Lovejoy right there. You can see Arcturus up here. And if I zoom out some, to give you a better view of the kind of field of view that HI2 has, you can see Mars and Venus down on the bottom right there. And if we go back to his video, you can see there's Mars and there's Venus in the video, and Arcturus up there. So yeah, he's looking at Comet Lovejoy and claiming it's Comet Linear. Alright, so let's move on to later in the video. So he does a jump cut from the stereo images to this close-up of apparently 209P linear. I don't know where he's pulling this image from, but he just kind of jumps to it and says, hey, here's a close-up. So let's listen in for a minute and see what he has to say about it.
Look at this close-up, guys. The brighter images of spots or stars. It's that cloudy debris field that I've got it as large as I can get it without total pixelation. That's 2.1 million miles wide.
2.1 million miles wide? Really? And he actually repeats that claim later on.
Yeah. We'll see. Again, here's your width of what you're looking at. And I went through...
There we go. Width of debris field, 2.1 million miles. Now, I don't know exactly where he's pulling this image from, but it doesn't matter. We can take our own image of Comet 209P linear and see if that's true or not. So last night, that's exactly what I did. I used my own telescope, my 8-inch LX200 Schmidt-Cassegrain, with an S-Big ST7 to take a picture of the comet, and it actually is in this picture, although it's not immediately obvious. In fact, it's this tiny little faint spot right there. Now, I've also overlaid a film plate from the Palomar Sky Survey on top of this image. And you can see all the stars match, but there's something flashing right here. And that's you can see it's present in my image, but not the Palomar Sky Survey plate. And that's because it's the comet, 209P linear. So I've astrometrically solved my image here, and I'll include this link in the video description as well, so you can examine it for yourself. And you can see the field of view is about half a degree wide. And using the WCS embedded FITS file, we can take a closer look at the size of the comet. So I've opened up the WCS embedded FITS file here, and you can see there's 209P linear. If you look up here in the top right corner, this window right here will show you a magnified view of anything I'm pointing at in the program. And you can see, okay, so there's the comet. It's a little hard to see, so we can set it to color intensity mode, and this will show you color based on the intensity of the pixels, and this gives you a little bit better contrast. Now you can clearly see where the comet is and how big it is. So if we measure the size of that circle, which completely encompasses the comet, the radius is about 7.3 arc seconds. So the comet has a diameter of about 14.6 arc seconds. And we know the distance as well, and not just because NASA says it's at a certain distance, but amateurs are taking pictures of the sky every night, including comets like this, and their data is also used to compute the orbit, and in fact, you can compute it yourself using just the amateur data. So that's what I've done here. I've excluded every professional observation. All of those professional observations are excluded here with an X on this column. The amateur data is the only data allowed in this solution. The professional data is still present, so you can see how well it fits to the amateur solution, and you can see it fits quite well. The professional data here is in parentheses. The amateur data is not in parentheses, and you can see it's got a tight fit to the solution, both the amateur and the professional. And what that means is that the professional data is telling the same thing that the amateur data is. The orbit is the same. Neither one is in disagreement with the other. So using this data, you can actually figure out the distance. The distance from Earth at the time that image was taken, these coordinates seen here are for the time the image was taken from where it was taken, and you can see the distance was about 0.61668 astronomical units. So if you do the math on this, at 14.3 arcseconds diameter and a distance of 0.61668 astronomical units, the total size of the comet comes to a whopping 4,000 miles. 4,000, not 2.1 million. So, yeah, he's completely wrong about that as well. He either has no idea what he's doing, or he's lying to you. In either case, he's not to be trusted. That's just how it is. I'm sorry. So, let's move on to another video here, where he's talking about linear. And he's got some guy named Michael on as a guest on his internet radio program, and they're talking about Comet Linear, and he's asking Michael whether they could be lying about when this comet's going to actually show up.
Now, I went in and looked at the speeds, and the only way to calculate is like the distance from Earth that the comet will be day to day. And this thing is varying so much. I don't know, from day to day, I don't know if it's something I'm not calculating in it, because they're both headed to the same intersection point. Now, and up until May 5th, it would make sense for linear to speed up, because for May 6th, that's the day of the closest approach to the sun. My point is this. Could those numbers be manipulated to give the people that have bunker space in timeshare enough a week or a month in advance other than what the public knew?
Absolutely.
I'm concerned
Absolutely.
about it. I wish you would look at that JPL model, and the next time we talk, just look at the math on it.
Okay, so he thinks that somehow the date of close approach to Earth and all that can be faked so as to give the elites more time to get to their bunkers by making it seem like it's later than it actually is, as if we're all freaking out about this. And no, you can't lie about it. Because if you did, the amateur data would no longer agree with the professional data, and we would know the true date of close approach by calculating it based on the amateur data. So you can see here I've got the orbital elements calculated from just the amateur data, and again, it matches my observation exactly. If we look at the coordinates of that circle I just showed you, so here are the predicted coordinates of the comet for the time the image was taken, and here are the detected coordinates. It's a perfect match to within a fraction of an arc second, and the resolution of the image I took is about 2.4 arc seconds per pixel. So yes, it's exactly where it should be in the image. Now in a second I'm going to show you more information about the orbit, which again is all calculated based on amateur data. NASA is out of this equation altogether. Professional observatories and observations are out of this equation altogether. And we're going to take a look and see what close approach actually looks like. So looking at some close approach data, we can see this is another solution that I generated from FindOrb using just the amateur data, and it gives you the close approach data in this case for Earth, and we can see that close approach is going to occur on May 29th at about 7:57 Universal Time at a distance of about 0.05546 astronomical units, and that is very, very close to what the professionals say. So they seem to be in agreement, and it's, again, not a threat to hit Earth or anything. I generated a series of Monte Carlo solutions from the amateur data to see what the uncertainty region looked like for close approach, and you can see that here I've loaded it up into Ursa, and let's center up on Earth and zoom in. And so this is May 29th, this is the date of close approach, and you can see the uncertainty region for 209P is concentrated into a tight little area right here. So even with just the amateur observations, we have a very, very certain determination of the orbit. We know precisely where the comet's going to be, and that it's not going to be a threat for impact or anything like that. And we know quite well how far away it will be and when it will be at that distance. So contrary to BPEarthWatch claim and his friend Michael's claim that they might be lying about the time or date of close approach to give themselves some extra time or whatever, no, they can't be lying about it. It is going to be May 29th. And that's from amateur data. That's not from NASA. That's not from professional observatories. That's just from amateurs like me looking up in the night sky and taking pictures of it. So we can also look backwards in time, because there is something interesting going on this year. Let me load up this one first. There is something interesting going on this year with 209P in that it might produce a visible meteor shower. Now, 209P itself, despite how close it's getting to Earth, the comet itself will not be visible to the naked eye unless it experiences a significant outburst. As you saw a moment ago, it's a very dim, faint comet, and even at close approach, it's only projected to reach about magnitude 10 or so, which is still invisible to the naked eye. You need a telescope to see it, despite the fact it will be one of the closer comets to come by Earth in history. Even so, it's still not the closest comet to come by Earth in history. Even in our own lifetime, we had a comet in 1983, Irasi-Ariki-Alcock, that approached Earth almost twice as close as 209P. And unlike 209P, it did reach naked eye magnitude. It was a more significant comet than this one. And it was also a long period comet, unlike this, which is a short period comet. And it did actually leave us with a meteor shower. Irasi-Ariki-Alcock is the progenitor for a very minor meteor shower, which also occurs in May, interestingly enough. Now, you can see, again, that close approach occurs on May 29th, but the point where we cross the point of closest intersection between the comet's orbit and our orbit is a few days before that, actually. Let me center up on Earth again and zoom in. And on May 24th, we cross that point of closest intersection between our orbit and the comet's orbit. That's only a few days before we reach the point of closest intersection to the comet itself. But you can see that on May 24th, we reach that point of closest intersection to its orbit, and that is the point where we might encounter meteoroids left behind by the comet on previous orbits, not on the current orbit. The comet's still back here. So if you go backwards in time, you can integrate the orbit backwards in time and basically rewind time and see what the comet's orbit looked like in history. Again, this is all from the amateur solution I generated and showed you. We're just taking that into ORSA and rewinding it. So if you go onto NASA's website right now, last I checked, the epoch of the orbit that they're showing for 209P is a few years ago. It's about 2007, I think. And at that time, the minimum orbit intersect distance equates to about 15 times the distance to the moon, 15 LD. And if you look here on ORSA, at a recent point in time, it's now 0.8 LD. Now again, this is not the close approach distance. This is the distance between the comet's orbit and our orbit. The close approach distance is much, much higher. That is, again, 0.05 astronomical units. But this is the distance between our respective orbits. And right now, it's at about a fraction of the distance to the moon. Now, why is that different from what NASA said? Well, if you go backwards in time, you'll see that 209P interacts gravitationally with Jupiter. Jupiter occasionally perturbs the comet's orbit. And a few years ago, the minimum orbit intersect distance was much higher. So you can see it's changing there. And back in about 2007 or so, it was indeed about 15 LD. You can see that there. So Jupiter's now perturbed the orbit and brought the comet's orbit closer to Earth. And that might allow us to run into meteoroids that had been left by the comet on previous orbits. Because about 100 to 200 years ago or so, the minimum orbit intersect distance was much lower. Again, Jupiter occasionally perturbs the comet's orbit. And you can see, okay, so now it's at about, in the early 19th century here, it's at about 4 LD. And at some point, I know I saw it before, yeah, it gets down to sub-LD distances. Let me go backwards. Okay, so yeah, here it's passing, about 2 times the distance to the moon's orbit. So yeah, it's possible that back in this time frame, it was leaving material very close to our orbit that we might run into this year. It's unknown, though, just how active the comet was back then. We've only been observing this comet for about the last 10 years or so, because, as I mentioned, even at close approach, it's still going to be too dim to see by eye. It's not something that people 100 or 200 years ago could have discovered on a close pass just by looking up in the night sky. You would have had to use a telescope. And even right now, just months before close approach, you need a very powerful telescope to be able to detect it. You need a large telescope, and you need digital imaging. You know, my 8-inch Schmidt Cassegrain with a ST7 CCD was barely able to detect this comet. It's very, very dim. Back in the film days, that would have been absolutely impossible to detect, because film is much less sensitive than a digital CCD. It takes more time for photons of light to generate a response on the film. And during that time, the comet is constantly moving. So if you don't already know where it is and you're not tracking with it, it will deposit its photons on different parts of the film over time, and it won't generate a usable image. It won't produce a detectable signal for you. So you need modern technology to be able to discover it. That's why we've only known about it for about the last decade. And therefore, we don't know how active it was back then. But even if it was active and leaving a lot of meteor material for us to run into, all it's going to do is produce a meteor shower. It'll just be a new meteor shower for us to look at. I mean, we see those all the time. Even in the extreme case that it produces a meteor storm, that's not unheard of. In 1999, the Leonids produced a meteor storm condition. You can see this is a 6-minute image, and in that 6-minute image, look how many meteors showed up. More than 6. We've got probably, about a dozen here? So you're talking about, 120 meteors an hour or so in just that region of sky. And even though this is looking towards the radiant, that is not, the meteors themselves are not confined to the radiant. Meteors during a meteor shower can appear at any point in the sky. They just trace back to the radiant. If you follow them back, they trace a line that traces back to the point where they're radiating from. So there may have been, and there probably were, even more meteors than this all over the sky at this time. So this was a very, very active meteor shower in 1999. And guess how many people died from it? None. It's not doomsday. It's just a pretty show in the sky. That's all it is. There's nothing to worry about here. And frankly, I would say odds are we're probably not going to see a meteor storm. If we're lucky, we will see a meteor shower. And as it turns out, North America is properly positioned to view it. Pretty much all of North America will be in darkness at the time that the meteor shower is expected to peak, if it does show up. So we here in North America have the best chance for being able to view it. So on May 24th, on the evening of May 24th, look up and look to the north and see if you see any sort of meteor shower going on. You might see some activity. It's possible, though, that the comet was too inactive back in this time frame for it to have deposited enough material to form a significant meteor shower or anything that we could detect above normal levels. So we really don't know at this point, but in no case is it doomsday. The deal with BPEarthWatch is, now he's on his 3rd comet now. This is the 3rd comet he's tried to fearmonger about. He started off with C2010X1 years ago. That failed to produce doom. So then he moved on to Comet ISON, and now he's on to 209P. How many more times are we going to do this? I guess every time. Every time a comet fails to produce doom, he'll just find another one to fearmonger about. Mark my words, when 209P fails to kill us, he'll start ranting about something, maybe sighting spring or something hitting Mars. It looks like now sighting spring is not going to hit Mars. We didn't know for sure at first, but I'll be doing more videos about sighting spring in the future. So, with that, I hope you have a nice day. The takeaway lesson here is do your homework, and don't trust what BPEarthWatch says. He's not selling you the truth. But he is selling you a bunch of videos for which he's monetizing, and he's making ad money off of it. For him, the motivation is getting attention, getting clicks, getting views on his videos. The more views he gets, the more money he gets. And that's, I guess that's just how it goes. I'll show this just cause some people might take offense to this, but I think it needs to be seen. If you go onto socialblade.com, you can see how much money people are probably making with their YouTube channels. He's making between $670 to $6,000 a month. That's a pretty significant monetary incentive to keep hyping the doom. you know, and keep getting the clicks. You'll notice on my channel, Astronomy Live, I don't monetize my videos. I make no money from my YouTube channel. So there is no monetary incentive for me. I'm just telling you guys the truth because I love astronomy and I hate to see it abused in this manner. And that's all there is to it. So I hope you all learned something today, and have a nice day. Hi folks, I've been noticing a disturbing trend in the last week or so of BPEarthWatch uploading video after video about Comet 209P linear, making all kinds of ridiculous doom-mongering, fear-mongering claims. You can see in the video titles here things like incoming debris cloud could strike major cities, the shaking of the Earth, linear's giant debris field, new images, etc., etc. And I've actually been getting messages about this from people concerned about it. So we're going to address these claims. We're going to take a look at these videos and see what the deal is. So in this first video, he presents what he claims is Comet 209P and the stereo ahead HI2 images. So let's listen in.
Here's linear coming in. It's still about to do its arc as it comes back through. You got
It's arc, okay, whatever that's supposed to mean. I'm sure that's the technical term, right? So he shows what he claims is linear there. And I've taken these images from the raw data on the stereo website and cropped down on that comet. And you can see here I've processed it. I processed the raw data to preserve the stars in the image so I could astrometrically solve it. And you can see there is indeed a comet present in these images. And you can see the astrometric solution here. I'll include this link in the video description so you can take a look for yourself. And you can see, okay, so we've got Arcturus up here. The comet's in the center of the image, and now we have the coordinates for the center of the image, so we can take a look and see what stereo head should see from its position in space when looking at those coordinates. So I've got that loaded up here in Starry Night Pro, and you can see at 13 hours, 30 minutes right ascension. Let's look again at those coordinates just so you can see. So 13 hours, 30 minutes right ascension, and about 18.5 degrees declination. And at 13 hours, 30 minutes right ascension, and about 18 degrees declination, we have Comet Lovejoy C2013 R1, a completely different comet than the one he's claiming. This comet is not coming particularly close to Earth, especially compared to Comet Linear. Now, Linear will be making a close approach by Earth, and it may even give us a meteor shower in May, but it's a very minor periodic comet, and it's not even the closest comet to come by Earth in our lifetimes. There was one that was much closer in 1983. And that one also left a meteor shower for us. And guess what? We're all still here, but more on that later. You can see Lovejoy right there. You can see Arcturus up here. And if I zoom out some, to give you a better view of the kind of field of view that HI2 has, you can see Mars and Venus down on the bottom right there. And if we go back to his video, you can see there's Mars and there's Venus in the video, and Arcturus up there. So yeah, he's looking at Comet Lovejoy and claiming it's Comet Linear. Alright, so let's move on to later in the video. So he does a jump cut from the stereo images to this close-up of apparently 29P linear. I don't know where he's pulling this image from, but he just kind of jumps to it and says, hey, here's a close-up. So let's listen in for a minute and see what he has to say about it.
look at this close up, guys. The brighter images of spots or stars